Scoped values versus ThreadLocal. It is a context propagation in modern Java. Why context sharing matters? Okay. Passing request context across layers without explicitly threading it through every method argument means context, right? So the passing the request context. What is the common use cases? User ID we can pass, identify who is making the request, and security context, authorization, roles and permissions, right? Then trace or correlation ID, track requests across microservices, locale and tenant info, multi-tenancy, isolation and language. Okay, so the traditional solution is ThreadLocal. What is ThreadLocal? Is per thread storage. Why? Because if you are making a call, if it is having a ThreadLocal, per thread there will be storage, so that it is isolated. Threads are isolated. Okay, thread 1 having its own storage, thread 2 having its own storage, thread 3 having its own storage. So it is ThreadLocal is thread safe because there is no overlapping. It is a isolated storage. So what is ThreadLocal? Per thread isolation. Okay, think of it as a map, thread comma t, hidden inside the thread itself. Is thread safe by design because it's isolated, right? Each thread having its own storage and it is isolated from other threads, so it is thread safe by design. So independent storage stores data per thread. Each thread gets its own independent copy of the variable. Lifecycle binding. Data lives as long as the thread lives, unless explicitly removed. This creates strong coupling with thread lifecycle. Ideal use cases. Great for thread confined state like simple date format or transaction contexts. The cleanup catch, although keys are weak references, values can still leak memory if remove is skipped. So ThreadLocal you understood, right? Is having independent storage, stores data per thread, and lifecycle binding. Data lives as long as the thread lives. Okay. So ideal use cases are great for thread confined state like symbol date format or transaction context. So cleanup catch is we have to use the remove at the end of the thread, otherwise values can still leak memory. Okay. How ThreadLocal works? Thread. Java execution thread. In Java we have multiple threads, right? So value tied to thread lifecycle in the beginning of the thread. Okay. Then we have a thread local map. Per thread local storage, we have thread local key value. Then not automatically cleaned value specific thread local object. So is lifecycle binding. As long as the thread lives, value will be there. Manual cleanup is required. Values are not automatically cleaned up. We have to do it manually. For that, we will use remove method. Okay. Pool danger. In thread pools, threads are reused. Old values can leak into new tasks if not cleared. Okay. If we are using thread pool, threads are reused. So Old values can leak into the new tasks if not cleared. So we have to remove it strictly at the end. Okay. So this is a Java example for ThreadLocal. You can create ThreadLocal like this. ThreadLocal string user equal to new ThreadLocal void handle request. We set the value, then we try. Inside try we are processing. After processing is done, we have to remove. That is very important to avoid the memory leakage. Okay. So inside process, it will get the data from ThreadLocal. Okay. So here user is a ThreadLocal object, and we set the value in the beginning, and we process. Inside process we get the value of the user, then at finally we will remove. This is the complete life cycle of a ThreadLocal object. Set, use, and remove. Okay. Then in the right side you can see user.set binds the value to the current thread. This value is now global to this thread. You must use try finally to ensure remove is called. So you can see we are removing from ThreadLocal inside finally block. Why? Because finally blocks will always execute, right? Even if in the try whatever happening, exception or error, whatever it is, the finally will get executed. That's why we are adding remove in the finally. Access anywhere. Inside process, user.get retrieves the value without passing parameters. So this ThreadLocal having a global scope within the thread. Okay, in this particular thread, you can access the ThreadLocal object anywhere. You don't need to pass it as a parameter, or you don't need to do anything. Once you declared this user, it's having a global scope across the thread, not across thread, inside the thread. Okay. Problems with ThreadLocal. ThreadLocal variables are global variables in disguise. They couple state to threads, creating hidden dependencies and brittle code. Makes debugging extremely difficult. Then key issues and risks. Okay, memory leaks. If you are not using remove, memory leak can occur. Thread pool pollution. Dirty threads can accidentally expose user A's data to user B in subsequent requests. Okay, async complexity. Context is lost when execution switches threads. Example, inside completable future or reactive streams. Virtual thread incompatibility. Creating thread locals for millions of virtual threads causes massive memory overhead. Okay. So these are the problems with ThreadLocal. What are scoped values? A modern lightweight mechanism for sharing immutable data within a strictly bounded lifecycle. Key characteristics: immutable values. Data cannot be modified after binding, ensuring thread safety. Automatic cleanup. No need for manual removal, cleaned up when scope exits. Explicit scope. Value is bound only for the duration of a specific code block. Virtual thread ready. Designed for high scalability and structured concurrency. Evolution, the official modern replacement for ThreadLocal. So, scoped values are an official modern replacement for ThreadLocal, because in virtual threads there will be millions of threads. So, scoped values is the best choice. We don't need to do clean up manually. Okay, it will automatically clean up. And immutable values. Data cannot be modified after binding. So thread safety is there. Explicit scope, value is bound only for the duration of the specific code block. Okay, after that it will get automatically unbound. So this is the diagram. Caller opens scope, binds value, it is immutable, cannot be updated, executes code, value accessible only inside dynamic scope, scope ends, value disappears. So this is the Java scoped values mechanism. Okay, dynamic scope, immutable, safety, leak proof. Scoped values, Java example. Okay, you can create a scoped value like this. Then inside handle request, scoped value dot where user equal to finish dot run process. So inside process user dot is bound. We are checking whether user is there. If yes, u equal to user dot get. Then we are getting it. So user is automatically unbound here. After the handle request, we done the processing. After that, user is automatically unbounded. We don't need to remove or anything. Okay, this is how scoped values works. So define the scope key. Scoped value dot new instance creates a unique immutable key. Unlike ThreadLocal, it doesn't store data itself. Okay, bind and execute, where key comma value dot run binds the value only for the execution of runnable. No manual cleanup needed. Zero memory leaks. Safe access. Use is bound to check availability safely. The value is strictly read-only and immutable. Scoped values key benefits. Designed explicitly for the modern Java concurrency model, prioritizing safety, clarity, and performance. Core advantages: no memory leaks, immutable safety, virtual thread ready, explicit lifecycle. Perfect for request context, tracing IDs, configuration flags. So it's a comparison. ThreadLocal is mutable, scoped value immutable. ThreadLocal lifecycle unbounded thread life. Scoped value strictly scoped block. Cleanup manual in ThreadLocal, scoped values automatic. Virtual threads risky and expensive. ThreadLocal is risky and expensive in virtual threads, but scoped values native support and lightweight. Inheritance complex. In ThreadLocal, scoped values structured concurrency support. So scoped values are recommended nowadays. Virtual threads impact. Virtual threads fundamentally change the thread lifecycle assumption, making traditional ThreadLocal patterns inefficient and risky. So massive scale concurrency. We can have millions of virtual threads. So ThreadLocal is very expensive in that case. In that case, scoped values are recommended. Key architectural shifts: short-lived and lightweight. Virtual threads are ephemeral and created in millions, unlike heavy platform threads. ThreadLocal friction. Duplicating ThreadLocal maps for millions of threads causes massive memory bloat. Carrier multiplexing. They mount unbound on a small pool of OS threads. ThreadLocal maps are costly to copy. Natural fit scoped values. Bind data to the logical execution scope, not the thread identity. Zero copy cost. ThreadLocal assumes threads are expensive resources to be reused. Virtual threads flip this assumption. So in virtual threads, scoped values are recommended, not ThreadLocal. When to use ThreadLocal? While scoped values are the modern standard, ThreadLocal remains essential for specific legacy and architectural patterns where strict scoping is difficult. Valid scenarios, legacy code and frameworks, thread-confined resources, complex migration paths, unmanaged threads. Migration to scoped values is recommended whenever moving to Java 21 plus. Okay, if you are still using an old version of Java, you don't have other choice. You have to use ThreadLocal. But from Java 21 onwards, scoped values are highly recommended. When to use scoped values? The modern default for implicit context propagation in Java 21 plus applications, immutable and safe, high performance. Recommended scenarios, new applications, request scoped data, virtual threads, config propagation. Best practice, use for immutable data with a clearly defined lifespan. Common mistakes, improper use of context propagation can lead to silent data corruption and severe memory leaks. Critical pitfalls to avoid, forgetting ThreadLocal dot remove, request context in thread pools, storing mutable objects, inheritable ThreadLocal risks, mixing patterns. So these are the common mistakes. So in interview, you can expect different types of questions regarding scoped values and ThreadLocal. Scoped values are safer and clearer for context propagation. It discuss memory leaks. Okay, the risk. Explain how ThreadLocal can cause leaks in the thread pools if remove is forgotten, as threads are reused and values persist. So this is the memory leak issue with the ThreadLocal. Highlight virtual threads. So you can highlight the virtual threads and scoped values. It's whereas ThreadLocal maps are too heavy but lightweight. Scoped values are designed for millions of virtual threads, whereas ThreadLocal maps are too heavy and break the lightweight assumption. Means virtual threads are lightweight and can handle millions of virtual threads. Dynamic scope versus thread storage. Clarify the shift from tying data to a thread's lifecycle to tying it to a strictly defined execution scope, making data flow explicit. So this is a summary. ThreadLocal scoped values. ThreadLocal traditional, scoped values modern. ThreadLocal is risky, mutable and thread bound. Scoped values are safe, structured and efficient. Future virtual threads. Scoped values are the native companion for virtual threads. Migration, adapt for new features. Migrate legacy slowly. Clarity, prioritize readable, explicit context passing. So thank you, and I will show you one live one demo in my IDE regarding this. So this is my anti-gravity IDE running here. So I will run my application and I will show you. So here ThreadLocal scoped value demo is a class. Here I have a ThreadLocal, inheritable ThreadLocal and scoped value. So let me run and see what's happening. You can see in the first thread is the standard ThreadLocal. Here this is the ThreadLocal, first standard ThreadLocal. We set the ThreadLocal value to parent value. Then we are simply printing thread.currentThread.getName. It is main because it's the main thread, right? So value is ThreadLocal dot get. So parent value, it's correctly printed. Then we have created a child thread. Here inside the child thread, we are setting the ThreadLocal set child value. So if we are printing, it is printing like thread 0. We created a thread, right? Then value is child value, because this ThreadLocal have set the value to child value. That's why here we are getting child value. Then outside child to thread, we are trying to print again ThreadLocal.get. Then you are getting null, because ThreadLocal is null here inside this thread, which means per thread there is a ThreadLocal. Okay, per thread, and it is isolated. That's why in the three cases you are getting three different values for ThreadLocal.get. Okay, then you can see parent after child threads, main value, parent value. Okay, here you can see I created two child thread. After that, I again simply in the outside of all threads I printed the thread name and value. It still prints parent value, because this thread is different. It's the main thread. Okay, and child threads are different, each thread having its own thread local. Okay, after remove ThreadLocal I am removing here. Then after removal I tried to print again, it is printing null. ThreadLocal.get is printing null. This is ThreadLocal. Okay, so now you can see inheritable ThreadLocal here. So inheritable ThreadLocal.set parent inherited value system.out.println current thread.get name inheritable ThreadLocal.get. Okay, so here in the second example you can see parent thread is main and value parent inherited value. Then we created a child thread. Inside the child thread we are printing the thread name and value. So here we are expecting parent inherited value. Okay, this is another thread, is a child thread. Inside child thread, what we are doing, we are printing the inheritable ThreadLocal.get. Okay, so what it is printing, inside child thread it is printing thread2 value equal to parent inherited value. That is the behavior of inheritable ThreadLocal. Even the child thread still getting the parent value from its parent. It is getting inherited inside the child thread, but it will not happen in normal ThreadLocal. Then scoped value. In scoped value, here you can see scoped value dot where scoped value a dot run system dot out inside scope a scoped value dot get. Scoped value dot get, here it is we are printing it. So where is scoped value? Okay, scoped value preview inside scope a scoped value a. Okay, inside scope a scoped value a, here we are setting like scoped value dot where scoped value comma scoped value a dot run. Then we are printing inside scope a scoped value dot get. Then it is printing scoped value a. Then nested scope, scoped value dot where scoped value b nested dot run inside scope b scoped value dot get. Inside scope b scoped value b nested. Correct? Okay, then it is coming outside the scope. System.out.println back in scope a scoped value dot get. It is again printing scoped value a. Okay, then if you come down, this after the scope we are printing outside scope is bound. Okay, outside scope is bound false, means we are not manually removing, still the value got removed. That is the advantage of scoped value. Okay, so scoped value, here we see two types of scopes and outside scope. So in that particular scope only that particular value will be available. Okay, thank you so much. Bye.